Here are solutions to perfect problem 3 for Math 111. All right, let's see. We have to find the midpoint between the centers of these two circles and then figure out if that midpoint is in either of those circles. Okay, so maybe the first thing we should do is figure out where the midpoint and what the radius of each of these circles are. So let's see, the way you want to do that is, let's see, we'll look at circle A over here and circle B over here. Let's see, circle A, in this form it's kind of hard to tell where the center and what the radius are, but if we sort of group the x terms over on one side and then group the y terms over here and maybe add 4 to both sides so we don't have this minus 4 anymore, then what we can do is complete the square on the x's and again on the y's, and we'll have it in our standard form. So let's see, to complete the square on this, we'll change x squared minus 2x to x minus 1 squared. But if you FOILed this out, you'd get x squared minus 2x and then plus 1. So we want to subtract 1 over here so that that plus 1 goes away and we end up with just what we have up top here. And then similarly over here, we do y minus 2 squared, but if you FOILed this out, you'd kind of have 4 too many. So we'll subtract 4 and get to here. And then finally, to get it into our standard form, just add 5 to both sides to get rid of this 1 and this 4. We'll get x minus 1 squared plus y minus 2 squared is equal to 9. And what's nice about this form right here is it tells us that the center is at 1, 2, and that the radius is equal to the square root of 9, which is 3. We can do that same thing over here for circle B. Maybe I'll change color so it's easier to keep straight what we got going on. Group our x terms, so x squared plus 6x. And then our y terms, we got y squared minus 8y. And maybe I'll subtract 24 from both sides to get to here. And then kind of like we did with circle A, we'll complete the square on the x terms. So this becomes x plus 3 squared. But this right here has a plus 9 at the end and this doesn't, so we have to subtract that 9 to keep our lines equal. And over here, completing the square on the y terms, we'd get y minus 4 squared. But to keep things equal, we have to subtract 16. And let's see, over here on the left, we have minus 9 and minus 16, which is negative 25. So we'll add 25 to both sides of the equation. Negative 24 plus 25 is just 1. So what we get is that our center is at negative 3, positive 4. And our radius is the square root of 1, which is just 1. Alright, so now we have a lot of the information. It's a long problem. There's still some more to do. The first part is to figure out the midpoint between these two centers. So let's see, we know that the midpoint between 2 points is the average of the x coordinates, so the average of 1 and negative 3. 1 plus negative 3 divided by 2. And then the y coordinate of the midpoint is the average of the y's, so 2 plus 4 over 2. This 2 and this 4. So let's see, 1 plus negative 3 is negative 2, divided by 2 is negative 1. 2 plus 4 is 6, divided by 2 is 3. So our midpoint here is negative 1, 3. So finally, what the question is asking for is this point negative 1, 3 in either of these circles? There's a lot of ways to figure out this answer. I think what I saw most people doing was kind of graphing things and just looking at whether it was in there or not. Maybe they gave some logic as to why. I think what I would do is figure out the distance from this point to one of these centers. Since it's in the middle, the distance from this point to this point is the same as the distance from this point to this point, right? Because it's the midpoint, it's right in the middle of the two. So I'll figure out the distance from this point to this point. remembering our distance formula, it's the square root of the sum of the squares of the difference in the x-coordinates and the difference in the y-coordinates. So what I mean by that is we could do 1 minus -1 squared plus 2 minus 3 squared. Right, so the distance between these two guys and the distance between these two guys, square them both, take the square root. So that is the square root of, let's see, 1 minus -1 is 2. 2 squared is 4. 2 minus 3 squared, 2 minus 3 is -1, squared is +1. So what we get is that the distance between this midpoint and either circle is the square root of 5. So let's see, 3 is the same as the square root of 9. So what that's saying is that the distance between the center of this circle and this midpoint right here is closer than the radius. In other words, this point right here is in this circle. Right, so midpoint, how about this? How about square root of 5 is less than 3. So midpoint is in circle A. But the square root of 5 is not less than 1. So, but not in circle B. I imagine very few people got the answer with this distance way, and you definitely didn't have to. I mean, graphing it is totally fine too. I just did it this way because I figured a lot of people didn't, and you might want to see one more way to do things. And if you do it this way, it uses our distance formula, which was the one thing from this section that otherwise would be lacking in this problem. So there's one solution to the perfect problem, and I guess that's the end of this video.